Good morning and welcome to recitation session. So we start with inverse function theorem and we not do the proof, but we do an example. So f of x is given as x power 3 plus 1 to the power of 3. And then you're told to find the derivative of f inverse. So recall that the definition or the formula that we proved in class, it's the derivative of an inverse function is given as 1 for the derivative at this point. So we can just say AB as xy. Now, let's recall that if this is y equals to f of x, if the function is one-to-one and continuous, then f inverse, if you take inverse on both sides, you get this is equals to x. So whatever you have here, y is equals to 8. And then in the function f of x, that is y, so 8 is equals to x cubed plus 1, all this cubed. So we want to find x. So to find x plus 3, we can solve this one by just looking at this one, or you just write 8 as this formation, which is just 2 to the power of 3, or all the factors of 8. It's 2 cubed. So that means that x cubed plus 1 equals to 2. So simply saying that x cubed is equals to 1. And that means that x is equals to 1. Now, issuing our formula, which I'm highlighting here, this one, we have that the derivative of f inverse at 8 is given as 1 over the derivative at 1. So we find the derivative of the function f prime of x, and in this one, as I have shown you, you use the chain rule, so which becomes 3. You fix whatever was inside, x cubed plus 1. Then by the power rule, the dropping of power, you get 2. Then you multiply by the derivative of the inner part of the function, that's 3x squared. You can simplify, but since we know the value of x, if you plug in x, you get the answer here to be 36. Now, that's f prime of x. So that means that the derivative of this inverse function is just equals to 1 over 36. That's the example number 1. Let's do second example in our recitation, and it's about the integral. So we evaluate this integral from lower limit e 3 dx over x natural log squared of x. So upon checking, we'll use the technique of U substitution. And let's recall this, if I'm having lower limit and upper limit as f, it is one, and then let's call the formulation of the formula dx. So we need to do substitution, and then we let u to be g of x. So we have, if we let u to be of g of x, then we'll be having the limits will change from g of a to g of b, and then we have a function, we'll be integrating a function of u with respect to u. So if you do inspect this function, you find that if you let g of x, which is equals to u, to be equals to natural log of x, you find that g prime of x, if you do the derivative, is equals to du, which is equals to 1 over x, if you check on it well. And that means that the integral changes to ln of e just by this part here, u equals ln of x. So the limit, when you substitute x with e, you get ln of e, and then ln of 3. And then the other part, dx over x, it's this part, sorry. That is becomes my du, and then ln of x, it's u, so you are squaring u. So this means that you are integrating ln of e, which is just 1, and ln of 3, and then u power minus 2 with respect to u. And this here you use the power rule method, whereby you add 1 to the power, you divide by the new power, then you use the fundamental theorem of calculus 2. So you get minus 1 over u. And then the limits of integration are 1 and ln of 3. When you substitute, you get that this is minus 1 ln of 3, then minus 1. Minus 1, so you get plus 1. So the answer becomes 1 minus 1 over ln of 3. That example, again, it's an integration. So you integrate 3 plus exponential to the power of x, all this squared. Then you divide this by exponential to the power of x, then with respect to x. So this is indefinite integral. And if you check on this well, you can expand the numerator part. You get 3 squared, that's 9, plus twice 3ex, that's 6ex, plus ex times ex, that is e2x. Then you divide all these by e to the power of x with respect to x. So this becomes, you split it, you get 9 e to the power of minus x. That's a step. Then because you're splitting it, 6ex over ex, that's a 6. And then e power 2x over ex is just e power x, because there are 2 copies in the numerator with respect to x. Then you apply the addition rule of integral. So you have 9 integral of e power minus x with respect to x plus integral of 6 with respect to x plus integral of ex with respect to x. So this one becomes 9. And then the integral here is just e to the power of minus x. Then you multiply by 1 over the derivative of minus x, that is just minus 1, plus the integral of 6 with respect to x is just 6x, plus the integral here of ex is just, again, e to the power of x. Then you multiply by 1 over the derivative of x, that is just 1. Then plus a constant c. So writing it in more clear manner, you get minus 9 e power minus x plus 6x plus e to the power of x plus a constant c. Number 4, we'll do the derivative of 3 raised to the power of root x. Again, this should not be confused with if x was the denominator. In this case, it's an exponential function. So what you do is that if you call y to be equals to 3 raised to the power of root x, this can be written as the same as e to the power of root x, then you attach natural logarithm of 3 because observe e to the power of natural log of 3 is just 3. And then if you put x, root x there, it's just 3 to the power of x. This is more easier to do the derivative because now the derivative of e ln of 3 root of x of 3, as I have said in the previous question, is just remember you write the way it was before, root x, then don't forget to multiply by the derivative of the numerator and the derivative of the power. And the derivative of the power is that n of 3 is just a constant, so you can just write it here, constant. So you differentiate x to the power of 2, x power a half. So a derivative x power a half is just a half, then x to the power of minus a half. So this one results to ln of 3. Then you have 2 square root of x. Then you multiply by exponential. Exponential power ln of 3 is just 3. Let me write it here first. Ln of 3, then add root x. So this one simplifies to ln of 3 divided by 2 square root of x. Then e ln of 3 is just 3. So times 3 to the power of root x. Finally, for today's recitation, we will do logarithmic differentiation. And the example that we do, it's the one that I gave in class. It's given y equals to x squared plus 1 secant x, this divided by x plus 1 under the root sign. Find the derivative using logarithmic differentiation. So what you do, you introduce natural log on both sides. Natural log of y equals to natural log of the whole of this complicated problem. So the steps here, you use the properties of natural logarithm. The property we are using here, let me give it as a hint. It's ln of a over b equals to natural log of a minus natural log of b. So be having natural log of x squared plus 1 secant x minus natural log of x plus 1 under the root sign. Now let's continue. We have natural log of y equals to The first part with the natural log here, it has product of two functions. So again, the second hint here, it's ln or natural log of a times b is equals to natural log of a add to natural log of b. You have this one becomes natural log of x squared plus 1 plus natural log of secant of x minus natural log of, now here write x plus 1, square root means power a half. Power a half. So now let's do the derivative. So let's do derivative, and I'll write that one using derivative with respect to x on both sides of ln of y is equals to derivative with respect to x of all this ln of x squared plus 1 plus ln of secant of x minus ln of, now another rule is you drop the power first in front of ln of x plus 1. That's the power rule of log. So this one becomes the first, it's like implicit differentiation. So you differentiate ln of y, and the derivative of ln of y, as we said, is that it's the derivative of the inner part, derivative of y, that is 1, and you attach the y prime, so it's y prime divided by the original function, which was inside the ln, which is equals to, let's differentiate again ln of this part, ln of x squared plus 1. So it's the derivative of x squared plus 1, that's 2x. You divide by the inner part in the ln, that is x squared plus 1. Let's continue, plus derivative of secant of x, it's secant x tan x. And for you to understand that one, is that you can write secant of x in terms of its primary form, that is 1 over cosine of x, and then you find the derivative of 1 over cosine of x using quotient rule. So then here you divide by secant of x because it's the inner function. Finally, the last part is that you get minus a half. Derivative of x plus 1 is just 1. Then you divide by the inner part of the function, that is x plus 1. Let's continue. You get y prime over y is equals to 2x over x squared plus 1. Secant and x and secant x will cancel, you get plus tan x. Then you minus 1 divided by twice x plus 1. Finally, because you wanted to find the derivative, so you'll be left with y prime on one side is equals to, you multiply by y, so you get y. Y is multiplying everything on the right-hand side, 2x over x squared plus 1 plus tan x minus 1 over twice in parentheses x plus 1. And now recall that y was equals to the function which was we started with, x squared plus 1 multiplied by secant x divided by square root of x plus 1. So you multiply it here. So you multiply this one to get the final answer of y prime is equals to x squared plus 1 secant x or sec x divided by square root of x plus 1. Then all that you multiply by 2x over x squared plus 1 plus tan x minus 1 over 2 in parentheses x plus 1. That marks the end of the recitation session. Have a good night.